Hey, welcome to lesson 4. We're going to learn to manipulate fractions in this lesson. But before I get started, I just want to let you know that I'm very proud of you for taking this step. It's hard to go back and learn these basic skills when either, you've just forgotten them or maybe you've never really understood them in the first place. So this is a fantastic step, and I know there's a lot of haters out there when you start trying to do the basic stuff. Don't listen to them. You just keep on going. Okay? So for fraction manipulation, we're going to manipulate the fraction by multiplication and division. And you can do anything you want to as far as that goes to a fraction, as long as you do it to the top and the bottom. Then you don't change the value of the fraction. For example, 1/2 of a pizza is the same as 2/4 because you multiplied both numbers by 2. So one thing we need to do is be able to tell what numbers go into others. Now lesson 1 is going to be your best friend here. If you went back and you reviewed all of those multiplication facts, and I will drop a link to the workbook down in the description if you want to grab yours. Otherwise you can just follow along. So there are some basic rules though that you can look at for larger numbers and tell whether or not they're divisible. And the first thing is, if it ends in an even number, then that number is divisible by 2. So let's look at all 4 of these numbers. Which ones are divisible by 2? Well, this one ends in 4, so it's divisible by 2. This is not an even number. This is not an even number, but 0 counts as an even number. So both of those would be divisible by 2, okay? All right, now let's look at 3. There's a little rule that says if you add all the digits up and they equal to 3 or a multiple of 3. What's a multiple of 3? 3, 6, 9, 12, 15, 18, 21. So if you can add all the digits up and they equal to 3 or a multiple of 3, then that number is divisible by 3. So let's test that. If I add all of these up, I've got 7, 8, 9 plus 4 is 13. 13 is not a multiple of 3, so 3 won't go into this. All right, if I add up 3 plus 5, that's 8, plus 1 is 9. 9 is a multiple of 3, so 3 would go into this number. All right, let's look at this one. 2 plus 7 is 9, and 9 plus 5 is 14. 14 is not a multiple of 3, so that's not going to work. Now let's go to this one. 9 and 7 is 16, 17, 18, 19, 21, 22. 22 is not a multiple of 3, so 3 won't go into that one. Okay, so you see how that works. Add them all up, see if it's a multiple of 3. Now for 5, that's pretty easy. If it ends in a 0 or a 5, it's a multiple of 5. So let's go. This is not 0 or 5. This is not 0 or 5. This one is. And this one is, okay? Then the last thing is 10. If it ends in a 0, it's divisible by 10. Well, the only one up here that's divisible by 10 is 9780, okay? So that's just one way to kind of look. That keeps you from having to divide these big numbers from every single number. And then you can expand it. For example, any number that is divisible by 2 and 3, that's divisible by 6. So if it's even, and then you add them all up and it's a multiple of 3, it goes for both 2 and 3, so you can say 6 will go into that, okay? All right, now let's look at our practice problems. Okay, let's have a look at these fractions now. When we want to reduce, we're going to reduce by division. And you can do, you can divide whatever you want to as long as you divide the top and the bottom by the same number. So let's look at these first two. 9 over 18. What's a number that goes into 9 and into 18? 9 does. So if I divide the top by 9 and the bottom by 9, what do I get? 1/2. Okay? All right, 6 and 18. Now do you see how lesson 1 is coming in handy here? Because you've practiced those facts, those kind of things jump out at you. All right, what will go into 6 and into 18? 6 will go into both of those. So if I divide the top by 6, that's 1. If I divide the bottom by 6, that's 3. So you've got 1/3. Now, 42 over 54, and I know for some of you that's going to jump right out at you, but I just want to show you another technique that you can use on some other problems if you don't happen to see that greatest common factor right off the bat. I do notice that both of these are even, so I could start out, I call this the whittling method. I'm just going to divide it by 2. That's going to get this down a lot smaller. So if I divide both of these by 2, that's 21 over 27. Now that's not lowest terms yet because there's still a number that will go into 21 and 27. What is it? 3. So if I divide both of these by 3, then I'm going to get 7/9, which is lowest terms. That's the whittling method. Now what would have been the best way to do it? The best way to do it would have been to look at these and say, you know, both of these are divisible by 6. 42 divided by 6 is 7, and 54 divided by 6 is 9. You would have gotten it in one step. And this is also what I mean. You know, it's easier to divide by 6 and get it the first time than to split it up and do it 2 by 3. But if you're trying to reduce a fraction and you just don't automatically see that greatest common factor, you can whittle on it. That's fine. You'll get the answer. Okay, our last one, obviously 5 goes into both of these numbers. So 10 divided by 5 is 2, and 25 divided by 5 is 5, and that is your fraction in lowest terms. Okay, on number 5, we start off with the fraction 2/3, and we want to fill in all these blanks with fractions that are equal to 2/3. So we're going to be going back to this original every single time, okay? All right, I'm going to start with my first one. Something over 12. Well, you ask yourself, what did I multiply this denominator by to get 12? Well, you had to multiply 3 times 4, so you want to do the same thing to the top. 2 times 4 would be 8. Okay. Now let's go back to the original. What did you multiply 2 times to get 50? Well, you multiplied this times 25, so you got to multiply this times 25. See, this is how you manipulate fractions. You change them to be things that you need them to be. All right, now we're here. What did you multiply 2 times to get the 6? Well, you said 2 times 3, so you got to do 3 times 3. So that increases to 9. And then the last one, you have a new denominator. So you say, what did I multiply the old denominator by to get 18? Well, you multiplied 3 by 6. So you have to multiply the 2 by 6. So that gives you 12. Okay, for number 6, we start off with 15 over 25. And we're going to do what we need to do to create equivalent fractions from all 4 of these. All right, so our first one, we have a new numerator. So what did I do from 15 to 3? I went down, so that's going to be division this time. All right, 15 divided by what is equal to 3? 15 divided by 5. So I have to do the same thing to the denominator. So that's going to give me a new denominator of 5. See, it's multiplication or division. That's what manipulates a fraction. All right, now let's go to the second one. I have a new denominator of 50. What did I multiply my old denominator by? Times 2. So I have to multiply the top times 2, and that gives me 30. All right, now on this one, I have a new numerator. So I come back to my original. What did you multiply 15 by to get 45? Well, that was times 3. So you have to multiply the bottom times 3. That gives you 75. Then we have another new numerator. What did you multiply 15 by to get 60? Well, that's times 4. So you have to multiply the bottom times 4. So that's going to be over 100. So for number 7, I ask you to circle all of the fractions that are not in lowest terms. So what you do is you look at numerator and denominator and you say, is there a number that will go into both of these? If the answer is yes, then you circle it because that's not lowest terms. All right, 4 and 8. Is there a number that will go into both of them? Yes, 4. So I'm going to circle that. That is not lowest terms. All right, 3 over 15. Will any number go into both of those? Yes, 3 will. So that one is not lowest terms. Okay, 2/3. Is there any number that will go into 2 and 3? No. So this is lowest terms. 7 halves. Is there a number that will go into 7 and 2? No. So we're not going to circle that one. And then this one down here, 10 over 8. Yes, that 2 will go into both of those. Okay? And I do want to stop and talk just a second here about the difference between lowest terms and improper fraction. This is an improper fraction, but it's still in lowest terms. Lowest terms means, and listen to me, lowest terms means there is no number that will go into numerator and denominator. You look at this. Is there a number that will go into 7 and 2? No. The numerator is larger, so that means it is improper, but that's fine. You can leave an improper fraction. This one here is improper, but it is also not lowest terms. If I reduce this down by dividing both of these by 2, that's 5/4. I could leave my answer like this, improper, because now it is lowest terms. Okay? And here in just a second, we're going to look at how to change this back to a mixed number. Okay, for number 8, every single problem up here is improper. That means the numerator is larger than the denominator. And we want to change it back to a mixed number. Now you have to understand, in a fraction, that denominator tells you how many pieces there are in a whole thing. For example, if I had a whole bunch of pizzas and I cut every pizza into 3 pieces, that's what's represented here. This denominator tells you how many pieces the whole thing was cut into in the first place. And now I look on the table and now there's 28 pieces there. So I want to go back and put these together and see how many pizzas do I have left. Well, how many pieces do I need to get to make a whole one? 3. So every time I grab 3 pieces out of this pile of 28, that makes one whole one. So now, mathematically, let's just ask ourselves, how many times will 3 go into 28 without going over? Well, it'll go in there 3 times, right? Oops, 9 times, sorry. 9 times, because 9 times 3 is 27. So this represents 27 pieces. If I subtract that 27 from the 28, there's going to be 1 piece left over, and that piece is 1/3, okay? So you ask yourself, how many times will the denominator go into this? And that becomes your whole number. Then whatever's left over is the numerator over that original denominator. Okay? 6 over 1. Anytime you have a number over 1, it is just that number. Okay? Now on this one, I'm going to show you the cheater way. Because you could, and it's not that hard. You can just say how many times will 12 go into 32 without going over. But if you have larger numbers, see, not only is this improper, it's also not lowest terms. So let's get it down to lowest terms first and then change it to improper. The numbers are a little bit easier to deal with. So what number do you notice right off the bat will go into both of these? Using the whittling method, I see they're both even. So I could reduce them down to 16, 32 divided by 2, and 12 divided by 2. Now it's still not lowest terms, because now what will go into both of them? 2 would go again, and that would be 8/3. You see how I just whittled on it? Now if you're smarter than me, you could have divided by 4 in the first place and gotten 8/3. And like I said, you don't even have to do this. You can just say, how many times will 12 go into 32? But we're going to say, how many times will 3 go into 8? Well, 3 will go into 8 2 times. And 2 times 3 is 6, so I'm going to say 8 minus 6 is 2. And then I'm going to use my original denominator, okay? Like I said, you didn't have to do all that. We could have, and let me show you, I could have stopped right here and said, how many times will 12 go into 32? Well, it won't go 3, because that would be 36. So it's got to be 2. 2 times 12 is 24. So if you do 32 minus 24, what do you get? You get 8/12. So you're still going to have to reduce that down to 2/3. But however you want to go about it. Everybody reasons through these differently, so I just wanted to show you as many possible alternatives as you can. As long as you just keep dividing the top and the bottom by the same number, you've not hurt anything, okay? Okay, and let's look at this last one, 63 over 18. So I could reduce it down, but I'm gonna work it this time, just going at it. How many times will 18 go into 63? And I'm thinking 3 times. All right, so let's do 18 times 3. 8 times 3 is 24, carry my 2. So that's 54. So now I want to do 63 minus 54. Oops. So that's going to be 9/18. Now, it is not improper anymore, but it's not lowest terms. I need to reduce the 9 over 18. What will go into both of those? 9 will. So when I divide both of these by 9, I get 1/2. So you can put it in lowest terms and then the mixed number, or you can put it in the mixed number and then in lowest terms. It doesn't matter. Okay, on our last set of problems, we're going to take mixed numbers. We're going to put them into improper fraction form. So I'm going to start here. What you do to change it is you multiply. Remember, the denominator, that tells you how many pieces there were in a whole. So if I cut all these pieces into thirds, and I have 3 whole pizzas left, well, 3 times 3 is 9. So there's 9 pieces. And then there's 2 random pieces sitting around over there. So that's 11. You add that. So you're going to multiply and then add. 3 times 3 is 9, plus 2 is 11. And then it always goes over that original denominator. Okay? Let's do it again. 5 times 1 is 5, plus 1 is 6, 6/5. Over here, 5 times 7 is 35, and 35 plus 3 is 38, and the denominator is always whatever the original was. All right, when you have a whole number, if you need to write it as a fraction, and there are times in algebra when we need to create a fraction from a whole number, you just put it over 1, whatever the whole number is. If I've got 5xy and I need to make it into a fraction, I can write 5xy over 1, and I just made a fraction. It's the same value, so, okay? So that's the end of lesson 4. We're fixing to move into lesson 5. Y'all are doing great. So hang in there with me, and I'll see you back here in the next lesson. Bye.